what we already have seen is that bijective functions have inverses. But what about non-bijective functions? Do they have inverses? Do they not have inverses? Well, the short answer is no. They do not have inverses. And to see that, let's consider the following example. Let's define the following function whose domain is given by the following Greek letters, so alpha, beta, gamma, and delta, and the codomain is 1, 2, 3, and 4. Well, we want a non-bijective function, so let it be the following assignment. So alpha and beta are assigned to 1, gamma is assigned to 3, and delta to 4. So f is our starting non-bijective function. Why is it non-bijective, first of all? Why is it not? Well, it's not because alpha and beta are assigned to 1, that automatically makes it non-1-to-1. And second of all, it's not onto. It's not onto because the range of f is 1, 3, and 4, while the codomain is 1, 2, 3, and 4. However, we could define f with the codomain being the same as the range by erasing the 2 here. This function is onto now, but it's not 1-to-1. The fact that it's 1-to-1 is the key point that you want to address if you want to at least get an inverse for this thing. Okay? This is not a non-bijective function. Well, but first, let us try to invert this function in a naive way. What would we do? Well, we would just flip the arrows. We would flip the arrows like this. So it's 1, 3, and 4. Well, this is easy, so you just flip this one, and we get this. You flip this one downstairs, but now, see, we have these two assignments to 1, we have to flip these 2 arrows. So you get this. This is a naive way of approaching the subject. Now the question is this a function or is this not a function? If you remember the definition, you should notice that the assignment for each element of the domain, we should have a unique assignment on the codomain. Can you see? You should have a unique assignment. But in this case, you don't have that unique assignment. You see, because 1 is assigned to alpha and 1 is assigned to beta. Another point of view of this, well, you just write the order pairs in this thing. So it's beta 1, so it's 3. No, it is the other way around, so 1 beta. So it's 3 gamma, and finally 4 delta. You see, the 1 here appears twice. So you can immediately see that it is not a function in this circumstance. So the idea is, because this is not 1-to-1, it's not bijective in turn, well, there is no inverse. Because anytime you attempt to reverse the arrows, you get something that is not a function. It is in fact a relation. But what we specifically want is the inverse function. Again, I want to stress this fact. Whether it's onto or not is irrelevant, because you can always set the codomain as being the range. The key issue is the fact that it is not 1-to-1. So we have to solve this problem if we still want to get something out of this. So let's do it. But first, let me write our f function here. So our f function is defined by the following order pairs that we have here. So gamma 3 and delta 4. Well, it is not 1-to-1. We can't invert it. So what we try to do now is to break this function into parts. We restrict this function into parts, but in such a way that each one of these parts are bijective. So let's do it. So for example, let's consider the first restriction to contain just alpha 1, and, for example, gamma 3. And the second restriction, let's call it h for simplicity, it could be beta 1 and delta 4. Can you see? These two functions are bijective. They are definitely one-to-one, and they are onto as well. If you define, of course, the domains as being the range, but you can always do that in every circumstance, okay? So this is the key point. These two functions now are bijective. Well, you can now get their inverses. So g minus 1, what is g minus 1? Well, you just flip the entries. Flipping the entries correspond to flipping the arrows. So you will get 1 alpha and 3 gamma. The same thing here. So you get h minus 1 to be 1 beta, and finally 4 delta. These two things are in fact functions, because the first entries, the year 1 and 3, only appear one time. Similarly, year 1 and 4 only appear one time. In the list, that is h minus 1. We had just avoided this situation, which is not a function. These two are functions. So this is the key point. The key point is that every single time that you have a not bijective function, in particular a non-one-to-one function, this is the main point of this thing, because you can always make a function onto. Well, you have to use restrictions to make them the restrictions bijective and then invert those. Now, I want to see something else here. This is not the only way in which you can restrict this function. You can choose other ways. For example, we could choose, for example, let's call it instead of this g, let's define another g prime, and g prime could contain just alpha 1. H prime could now contain the beta 1, the gamma 3, and delta 4. Can you see? I hope you can see these now are two bijective functions. You just put these into these very basic functions, just one order pair, one assignment, and the remaining ones. These two functions are now bijective. You can just compute the inverses just by flipping the entries in each one. So there are many ways. For a single function like this, non-bijective function, there are many ways in which you can compute the inverses, not of the original one, but of the restrictions that you choose to create. This is the key takeaway. Now let's see a more sophisticated example with the squared function. Let's see.